Okay, guys, so earlier today I made a lecture for another class, and it consisted of like a PowerPoint video similar to what I did for y'all last week. And the file was so large, it took like 6 hours to upload and counting. It hasn't uploaded yet. So for chain rule, which is what we're fixing to look at, I'm going to make it into two different parts, and it'll mostly be just audio, so the file isn't as large. So FYI, don't do that. Bye. Okay, for this one, you can either do the quotient rule and the chain rule, or you can change it and just do the chain rule. I would highly recommend changing it and just doing the chain rule. So I'm going to rewrite it. To the -3 power, because if it's on the denominator and it has a power of 3, then when you move it to the numerator, it has a power of -3. So to find the derivative, we have two functions now. We have this outside power, and we have this inside function. So let's take care of the outside power. So we bring the power down. Oh, and we also had a 1 out there, didn't we? And then we have 2x to the 5th, leave the inside alone, and the new power is 1 less, so it's -4. And then we need to multiply by the derivative of this inside, and the derivative of 2x to the 5th is 10x to the 4th. If we then simplify this mess, we're going to get -3 times 1 times 10, so -30 x to the 4th over 2x to the 5th minus 7 to the -4. Oh, sorry, +4. It's interesting to note here that this would not have been this easy if you had done the quotient rule. Now, for this one, it would have been kind of as easy, but in general, definitely want to change it to just chain rule and not quotient and chain. To this point, we haven't really talked about trig functions a lot, but one thing I wanted you to note is if you look at this top function, this is sine, and down below in orange, I graphed the derivative, and you can graph that using Desmos. And interesting to note is that on the top function, you have, for sine, you have the point 0, 0. But for this one, you have the point 0, 1. So, turns out that the derivative of sine is cosine. So it's like the easiest derivative in the world. So the derivative of sine is cosine. This slide talks about all the different derivatives for the trig functions, which are actually pretty easy to come up with. The main ones you kind of would want to focus on are these first three. The derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent is secant squared. And I could show you proofs of all of those. I doubt that you want to see them. Also of note is that there are actually hundreds of derivative formulas in the back in front of calculus textbooks. So trying to memorize everything is futile. It's more important that you be able to look it up and figure out how to use it. Okay, so the next three problems, they're going to say example 9 continued, example 9 continued. I thought about what is most confusing for students, and I wanted to show you an example of three types that look similar but are very, very different. So here's the first one. It says the function g of x is sine of x cubed minus 3x. So I want you to think about, looking at this problem, what rule I would use for this. Would I use product rule, quotient rule, chain rule, power rule, trig derivative. There's so many that we have. E to the x, natural log of x, 2 to the x. So we have so many different rules. Which one would apply to this? Well, it turns out for this one, this is the chain rule only. Chain rule, well, and also power rule. Oops, let me power. And also, it's got some trig in there, guys. So we actually have 3 rules for this one. We got to do chain, power, and trig. So chain is the one I'll focus on the most. Chain, we go outside in. So we have our outside function sine, and we have our inside function x cubed minus 3x. So for our derivative, g prime of x, which derivative is our slope, right? We first take the derivative of sine, which is cosine. Leave the inside alone. Then we multiply. And what are we going to multiply by? The derivative of the inside. So this red part. And the derivative of x cubed is 3x squared. And the derivative of negative 3x is minus 3, or negative 3. And that is our final answer. How is this one different from the last one? It looks almost identical. Here's what makes it not identical. This x. The last one, it was sine of x cubed minus 3x. This one is sine of x times x cubed minus 3x. So this is totally a product rule problem. That's it. It's not chain rule. It's not quotient. It's not, well, it's product, and also we have some power, right? We have a power in there. We have x cubed. So let's get to the derivative. So this is a product rule situation. So we have one function times another. So for the derivative, let's use a different color. For the derivative, f prime of x, we have first function times the derivative of the second function. And the derivative of x cubed minus 3x is 3x squared minus 3. Plus the second function times the derivative of the first function, and the derivative of sine is cosine. And that would be our final answer. Okay, so this is our last example number 9, our third example number 9, if you will. And what makes this different? This one is like the last one. It is the product rule. But also, it has some trig in there, as the last one did. It has the power rule. And it also has the chain rule. Oh God, guys, this is a lot. Now, I think what's confusing oftentimes for students is which one to do first. Well, let's look. We have sine x times this monstrosity. And so we need to do product rule first. Okay, so let's start. Product rule, we have h prime. Let's do sine in red. So we have first function times the derivative of the second plus the second function times the derivative of the first. Okay. All right. And I should write this one. This is the second function. So we have first function times the derivative of the second plus the second function times the derivative of the first function. Okay, here lies the hard work. Let's look at the second one down here. we have the second function times the derivative of the first function. The derivative of sine is cosine. That was easy. Okay, so at this point, here's what we've done. We have done our product rule. We've done the trig. Now we got to do the chain rule. And where are we going to do the chain rule? We're going to do the chain rule in this function right here. See this power of 5 on the outside? And then this function on the inside. So we have sine of x first function. Now we have to do the derivative of the second function, which is totally going to be a chain rule. So we start outside in. So bring the 5 down, the power down. Leave the inside alone. And the new power is 1 less, so 4. Now we have to multiply by the derivative of the inside, and the derivative of x cubed is 3x squared. And the derivative of minus 3x is minus 3. That, guys, is the answer. Now, could I simplify it? Maybe I would leave that mess alone. Awful. Okay, please don't hate me. I was trying to think of what is the worst case scenario. The last one was pretty bad. This one is also fun. Okay, we have power here, right? And we have an inside function here. Okay, so we definitely have chain rule. But look at that inside function. That is a quotient. So we're also going to have to do quotient rule. So which one do I do first? The power, because it's on the outside. So let's start. Let's take our time. So the derivative, first do that power. So bring the power down, leave the inside alone. Oh, my t's look like pluses. And the new power is 1 less. And then that is multiplied by the derivative of the inside function. Okay, but the derivative of the inside function is the quotient rule. So the quotient rule is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, let's go back and look. Did we do it all? We did the outside power, which is 3, left the inside alone, new power is 2. Then we multiplied by and found the derivative of the inside function in red, and that is the quotient rule, which is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Can I simplify this? Yes, you're probably not going to like it. You could simplify this into what? It's going to be nasty. 3 times t cubed minus 2t plus 1 squared. Okay, over t to the 4th plus 3 to the 4th. Where did that 4th come from? Well, right here is a square, right here is a square. And so I combine this with that one. Okay, now on the top, this is times, oh God, it's going to be horrible, 3t to the 6th minus 2t to the 4th plus 9t squared minus 6 minus 4t to the 6th plus 8t to the 4th minus 4t cubed. Gross, guys, gross. And you could go on from there. Oh, I'm over it. I'm stopping. I would leave it on that first step. Last problem of the chain rule section, and it is fun. Okay, so here's what we have. We have two functions multiplied together, right there, right? So multiplied together part, right there, in the middle. And both functions are chain rule. So we are going to have to do the product rule because we have two things multiplied together. And we're going to have to do the chain rule because each thing that's multiplied also has some powers. So let's start. So G prime, we have the first function times the derivative of the second plus the second function times the derivative of the first. Okay, so first times the derivative of the second plus the second times the derivative of the first. And so that's the product rule. Check. Now we need to do the chain rule. So we have first function times the derivative of the second. Let's look at the second. We have this power here, 3, and we have the inside function. So we take care of the 3 first. So we bring the 3 down, leave the inside alone, and the derivative is 2. Yeah, so 1 power less. Then we take care of the red part. So we multiply, and the derivative of the red is negative 7x to the negative 8. And that's it. Okay, so first function times the derivative of the second plus the second function times the derivative of the first. So the derivative of the first, we have this power here, and we have this inside function here. So we first take care of the power, so we bring the power down and leave the inside alone. Our new power is 4. Then we multiply, and the derivative of the inside is going to be derivative of 2 is 0, and the next term, the derivative will be negative 8x. So that is it. We're done with this one, and we're done with this lesson. All I would ever expect out of you on a test is this very first step. So please do not freak out. The ones on the homework should not be this hard. I just wanted to show you what can happen. All right. Again, the homework can be found on my math lab. It's the same 13 problems for part 1 and part 2, so just do your best to work through the problems and let me know if you have any issues.